In software engineering, we are taking chapter number 9, requirements modeling, and we'll talk about the scenario-based methods. So requirement modeling has come from the understanding of requirement gathering, requirements analysis. So when you have generated the requirement, that is what the user want, what are the stakeholders' requirements, then you have to analyze it. Okay, first draft of requirements have to be analyzed, and then we have to make the models. So the requirement models, there are different ways of doing it. So this is the first ever technical representation of a system or a software to be built. I hope you got the idea. So this requirement analysis, when it is done, which is, you can say, the refinement and cleaning and elaboration of requirements, what do we get? The first thing we get is what are the software's operational characteristics. When it will operate, what are the functions, what are the features. Then, because the software will consist of various system elements, various parts, how the interfacing will work, how they are going to be interfaced, and there will be certain constraint. That is, you have to be inside this or you cannot go outside this. In both ways, this requirement analysis establishes the constraints, the boundary that the software need to attain and must meet. So in all, if you see, this requirement analysis is all about whosoever, like the software engineer, the analyst, the modeler. So this analysis is the elaboration, stretching, cleaning, refinement on the requirement of the requirement which has been established or you got through inception, elicitation and negotiation task. And these are all the part of what? Requirements engineering. So requirements engineering, you are going to analyze it now. So there are certain types of models we are going to generate as a requirement engineer. Because if you make a big building, the models have to be seen. So there are various ways, there are various projects, there are various domains, different kinds of models can be made. For example, the scenario-based model. That is, how many actors we have, and these actors, how do they see the system? These actors' requirement from the point of view of these actors, when we make this is called scenario-based model. Then we have the class-oriented model. The class-oriented model, it defines what will be the class. That is the different class we can define the problem. And these classes are nothing but objects, because objects are the instantiation of the class. And these classes, these objects, what will be the characteristic of each class, that is the variable, and what are the functions, that is the say operations, and what are the relationship among different classes that has been found out in class-oriented model. Then the behavioral and pattern-based models. This shows that if something happens or some external event, some trigger is there, how the software is going to behave, to act, to respond. Data models, because here data is involved. So every information domain, because the data is different. So this is considered here. That is in network, what is the data and how this data is going to be presented. So this shows how data transform inside the system, like the data flow models we are going to make here. Okay. Then we have the flow oriented model. So this shows how data transform inside the system, as I said. Which data? From the data model. So the flow oriented model, it shows the functional elements of the system and how they transform the data. So flow oriented shows how data are transformed by different function. While the data transform from one point to another, the functions are involved. So this is also being taken care here. So on the basis of this requirement modeling, this software designer, that is the person who is going to design the software, he will use these models, all of them or few of them, for the design purpose. For example, architectural, interfacing, component level designs. This will be done by on the basis of, or from the help from these all requirement modeling. So requirement modeling or requirement engineering, for example, you are making or you have created a software requirement specification. Once you have done, this will be helpful to you also and the customer or the stakeholder. That is, the quality of the software can be assessed. The quality can be verified, validated by the means of the requirement model which has been created. Let us say we have created SRS, Software Requirement Specification. So for the requirement modeling or requirement understanding, what is the primary focus when we are actually doing the analysis modeling? This is based on the question what, not how. We are not going into the detail. We are just saying what is required, what is the user requirement, what is we are going to do. So we don't go to the implementation detail or how. So whenever we are making a requirement model, there are certain objectives, there are certain goals. So three primary objectives have to be seen. First is what the customers require. And once you make the requirement model, this is the basis for the software design. Will be the basis. And once the requirements are ready, these can be validated. Once the software is created, built and delivered. Now you see here, this analysis model is actually a bridge or it fills a gap between the system level description and the software design. That is, when you describe the proper system things and you go to the design, you cannot directly jump from what you have got from the user and go to the design model. No, you have to make certain analysis model. So this is the bridging of the gap. All the elements of the requirement model shall be directly traceable to the parts of the design model. That is, requirement model is the basis of the design model. Design can only come when you have a proper analysis model of the requirements which you gathered in the requirement engineering. Okay. So this analysis model and design model, they have certain things in common. What does it mean? There is some intersection point. So some analysis will be conducted during the design and some design will be conducted during the analysis. Okay. Analysis will have some part of the design and design will have some part of the analysis. That is why we are saying these are quite close thing. Design can only come when you have a good analysis model. So when you do the requirement analysis, requirement modeling, there are rules of thumb given by various giants in the software engineering field. For example, Arlo and Newstead, they gave the rules of thumb for creating the analysis model. That is the requirement analysis model. What are they? First is the model you are creating. They should focus on the highest level, that is the requirement that are visible within the business domain. The work, the job, the business for which you are making the software, the level of abstraction should be very high. You have to think of full software as whole. Don't go into the details here. The level of abstraction can be high here. Only talking about the business domain which will be visible clearly to the user. Each element of the requirement model need to add some kind of additional thing plus to the understanding of software requirement. For example, this analysis model you have made from certain requirements. The analysis model, why you are making? You are adding certain things to requirement. Then only it is good. For example, if I write 2 by 3. Now you will ask, is it the address of some house? When I write 2 divided by 3. So 2 by 3 has come from the requirement, and 2 div 3 has come from the requirement model or analysis model. So whenever we are going to the third point is, whenever we want to go to inside, like the infrastructure, like the design details, like the non-functional models, until design we can delay it. No need to discuss all these things here. And we have to minimize the coupling throughout the system, because while we are doing this analysis model, there are different parts, subsystem part. So we need to see that the close relationship should not be there. We need to have as less coupling as possible. Okay? If you're making 2 classes, they need to have as less coupling as possible. Then, as I said, the requirement model needs to provide some value to the stakeholder. Because if you have written requirement and you have not done anything for the analysis model, why are you doing this analysis model? It has to add certain values, some pluses to the stakeholders. And the most important is keep it simple. You may be technically very advanced, but the people for whom you are making the software, it needs to be as simple so that the designer can understand, coder can understand, tester can understand, the maintainer can understand, and also you can understand. Domain analysis. Domain is all about the field you are working. For example, you are working in computer science. Computer science is a domain. Now, networking in computer science is another domain, right? In network, I am working with switches, another domain. So this is the domain you are talking about. That is the actual piece of work where the software is going to be implemented and executed and will be worked upon. Now here comes the analysis pattern. That is solving very common problems. Every software developer who has got experience, he knows that certain things will come up again and again. So once we create the analysis model of already known common problems, such as analysis patterns we are calling it, we can use it. Because in networking, you know the TCP IP socket or pipe or whichever way IPC you have to use. You know the common problems. These are called the analysis patterns. And once you use the analysis pattern, it becomes very easy to understand that the design patterns and the software component can be applied. Because this design pattern and software components will increase the value and make your software to the market, and the cost will be reduced. What I'm trying to suggest is, using the analysis pattern, consequently the design pattern and software component will improve the time to market and reduce the development cost. Now the question comes, how are analysis pattern and class recognized? Who is going to define them? Who is going to categorize them? Who will do it for the subsequent project? Because this is not the only project your company may be handling. So who is going to find out this analysis pattern and the classes? Okay. This can be applied to subsequent project. So we need to define it. There has to be someone. So thus that guy is called as the domain analyst, and the work he does is domain analysis. So Firesmith, he described his domain analysis in certain ways. He says that the software domain analysis is the finding out, identification, analysis, and specification of the common requirement for a specific application domain, as I suggested, networking, switches. And these are typically for reuse on the multiple project within that application domain. A networking company, software company, can have multiple projects on networks. So software domain analysis is all about finding so that it can be reused in different application domain, right? So it is all about identification, analysis, and specification of common requirement. When you specifically go to object-oriented domain analysis, here we are trying to find out what? What will be the classes? What will be the objects? What will be the sub-assemblies? Subclasses you can say. What are the frameworks? So this is the domain analysis. Okay, there are two things: reuse and then applying it to multiple projects. What is the goal? What is the, say, end point you want to achieve? First, you want to create or to find or create those analysis classes or patterns that may be reused. So main thing is reusing and finding out the analysis class and pattern. So this domain analysis is not only pertaining to this requirement modeling. It is an umbrella activity for the whole software development life cycle. This activity will be carried out. For example, a domain analysis. You can consider him to be equal to a master toolsmith. If there is a very heavy manufacturing environment, say car making, then there will be a toolsmith. Now the job of toolsmith is what? He will design and build tools and give it to you or give it to people who are doing similar kind of job but not the same job. That is, they are in different projects and they are doing similar kind of work. So he will make the tool once and he will give one to one project team, one to another project team. This is the domain analysis. If you see here, what are the inputs and the outputs you are going to get? How do you get to do the domain analysis? What are the inputs? The final will be the domain analysis model. So the sources can be immense. It can even come from, say, let us take an example. It is a medical science field. You are making a software. So what will be the technical literature? What are the applications which are already being used by the company or the other companies for the same thing? You can use the medical science people, doctors, and the other supporting people to get the customer survey. You can get the expert device or the current and future requirement. Finally, you will get the result as class taxonomies, reuse standards, functional models, and the domain languages. These will be the outputs. Finally, you'll get the domain analysis model. So there are different approaches in requirement modeling. These approaches, what are the product will be different, the way will be different. First approach is the structured analysis. Structure analysis is all about functions. So here it considers the data and the processes, that is the functions, as different entities. They are not in a capsule like object oriented. So data object will define their attributes and the relationships. Okay. So processes are modeled in such a manner that they will show how they transform the data. This is structured analysis, basically the functional way of programming, functional way of understanding, the structural way of understanding. And when it comes to object-oriented analysis, this is focusing on the classes. Classes will give rise to objects, and these classes, what they are going to collaborate, how they are going to be worked upon, so that the customer requirements can be fulfilled. Let me more exemplify it using the detail. Structured is the methodology is conventional way, software development life cycle, like the waterfalls, like the spirals. Object-oriented, the methodology is iterative and incremental. When we talk about focus, structured is processes. It is focusing on processes. Object-oriented focusing on the objects. When we talk about risk, in structured it is quite high. Object-oriented it is low. Reuse very less in structured, very high in object-oriented. The structured way of requirement modeling is mature and widespread. Object-oriented still emerging, but now it is also mature and widespread. When your project is well defined, these requirements are well defined, structured way of approach you can use. But when the projects are large and the requirements are ever changing, you have to use the object-oriented. So if you see the analysis design in structured, you will create analysis model as DFDs, structured English, ER analysis. And when you come to object-oriented, use case, activity, flow of events, mainly the UML diagrams. In the design, there will be different way of DB design, UI design like this. In object-oriented, there will be a proper way. There will be an architecture, there will be design classes and how we can combine the classes, eliminate the classes, split the classes, what are the components we are going to use. This is how we will go after the object-oriented. So these are the two requirement modeling approaches. The software requirement is the center point here. And when we talk about requirement modeling approaches, each element of the requirement model has to present problem from a different view, different mode, different eyes, different point of view. So basically we are just taking the software requirement and then we are making certain model. Okay. So main idea is different perspective. And these all are models being created. For example, scenario-based model. This is showing how the user interact with the system and the sequence of activity that occur, the flow of activities that occur as the software is used by certain actor or certain people. So in scenario-based, you will create use cases, use stories. In class-based element or this model, the objects, that is of course the functions, that will be manipulating these. So relationship between the classes, objects, collaboration between the classes will be shown here. For example, class diagram, collaboration diagram. When behavioral elements you are going to make, this will show how external events, external triggers change the state of the system. You will make the state diagram, sequence diagram. Flow-oriented model, it shows the data objects, how they are transformed as they flow through various system functions. You will make DFDs, that is the data flow diagrams, the data models in the flow models. So these are different way of modeling, and analysis modeling lead to the derivation of all of these or few of these modeling elements. It depends on you want to create use cases or DFDs. Okay, we will be taking one more part of this, so we'll be discussing it later. Thank you so much. Take care of yourself.